Hi everyone, I'm Francesco. I work for Red Hat in the AI Center of Excellence and Office of the CTO, and I'm very happy to be here at the Open Data Science Conference West 2021. Today we will talk about reproducibility and dependencies for Jupyter notebooks, and in particular, after an initial intro to the Jupyter notebooks, I will describe the problem we are trying to solve. Then I will introduce Project Thoth, one of the projects in the AI Center of Excellence at Red Hat, and the solution we introduced to solve that problem. Then I will describe one tutorial you can do using the solution proposed, and finally we will conclude with the lesson learned. So let's start with the Jupyter notebooks. Jupyter notebooks are an interactive web-based application that allows you to create and share these documents that have basically contents that is live code, visualization, equations, text. And these Jupyter notebooks can be used with a variety of languages. Today we will focus on the most used, especially in the data science domain, which is Python. They are heavily adopted today in many industries and fields, like for rapid prototyping, tutorials, analytics, and visualization, for running experiment. And actually they are trusted by many big companies today. So what is the problem we are trying to solve? Let's start with a computer vision example. Let's say I am a data scientist and I want to create a computer vision application. And the first thing I want to do is to install the dependencies. So for example, I can run pip install OpenCV Python to get OpenCV. What is OpenCV in this case? OpenCV in this case is considered a direct dependency of my application. And I can install it simply running this command. But when I install this package, I can also get transitive dependencies. For example, NumPy is one transitive dependency of OpenCV Python. So when I install a specific package, I can see that there are other packages coming with that. And you will see why this is important. And what about the versions? Do we get a specific version? So if we check the number of releases of OpenCV Python and NumPy, you can see that there are quite a lot of releases created. And if we have a look actually at when they are released, you can see that, for example, for NumPy, these releases are quite often. There is at least one per month. And this means that if I run my notebook with that command today and I run it in 1 month, you will get a different version of NumPy because you're not stating anything about this version. And this is fundamental if we want to reach the reproducibility goal that we want. So, but let's go a little bit further. What about the hashes? So hashes basically are a way to guarantee provenance of the packages. So if we want to make sure that something was installed from a certain index. And so also this one should be available when you give this notebook to someone else. But we can also consider Python interpreter. So I can run this code on Python 3.6, 3.8, 3.10, and all of them could like introduce some new feature or should be considered for the reproducibility. Do we consider something more? Let's have a look at this complete stack and layers. As you can see, there are many layers in an application, and talking about Python application. And as you can see, all of this can basically break your code, either when you want to build the application or when you want to run the application. Maybe you miss some specific library, or maybe some native dependency is missing, and therefore you cannot even run the notebook. And as we said, if we use like something like that command with no dependency, not even a version stated, then we are not going to reach that goal that we want, which is the reproducibility. This is a typical example that you find in many notebooks. So we can install directly the dependency from the notebook cells. But as we said, this will not guarantee that the reproducibility will be obtained. Another example might be using some manifest file like the requirement.txt, which used in this way would not guarantee the reproducibility. There are ways to write the manifest, including all the version for all the dependencies, direct and transitive, and also for all the hashes. So there are ways to do that. But in this case, if we just state the name of the packages, we are not going to to obtain the reproducibility. So as you can see, if we think about the Jupyter notebook itself, they are by default not standalone. You cannot give someone a Jupyter notebook and expect that that would work in my machine, on another machine, with another Python interpreter, with another transitive dependency installed. So this basically do not allow the reproducibility and shareability, and also put a constraint on the authors because they need to provide always this manifest together with the notebooks, which are decoupled in this case. This is also a problem when you want to containerize these notebooks. If you want to ship them and provide them with to someone, then you need to make sure that, for example, the Docker file, the container file, is able to address the dependencies. And last, when someone wants to consume this this package, then they're not able to do that because unless you provide them with all the manifest and everything that was related to that environment. So to summarize a bit, what are the difficulties for both the authors and consumers, and what kind of task should be considered in order to help them in this in achieving this goal? So you know that the authors needs to create this environment. Typically, they need to create a virtual environment, and this virtual environment should be not polluted by any dependencies. Then they need to install these dependencies. They need to create a kernel and update that kernel every time they add a new dependency. And they also need to, in theory, maintain some manifest if they are using this requirements.txt or the pip file lock used by pipenv. So there are different files that could be maintained, but in general, we see that the manifests are not always provided, and those commands, as we mentioned before, are not going to guarantee reproducibility. On the consumer side, instead, I want to receive the notebook and say, okay, now I want to just install it and run it. But if I don't have any other manifest at the moment, I cannot guarantee that that notebook will work if someone created it 2 months ago or 3 years ago. And of course, we need to create a custom kernel in order to run the specific notebook. So all these tasks are some important tasks for the users, either authors or consumers, and we could actually help them in doing this. We could help them, especially if we want to keep the dependency up to date between the manifest and the notebook. So this would really help them, especially the authors. And actually, we could also help achieving the reproducibility. So when I give this notebook to someone else, then the user will be able to reproduce the same environment because we know everything about that. So what we can do? Before we move ahead, I will basically introduce Project Thoth, and then we will move to the solution implemented in Project Thoth in order to guarantee and help the authors or consumers working with this reproducibility problem. So Project Thoth is a project developed inside the AI Center of Excellence at Red Hat. We provide a system and a user-facing service. It's basically an API that is able to provide you with recommendation on your software stack. We also deliver optimized, secure, well-maintained, and predictable images because the problem of reproducibility also impact the predictability of the images. So if you want to rebuild the same image for AI applications, and then we automate basically maintaining the dependencies and building these images thanks to bots and pipelines. We observe a variety of knowledge. So there are knowledge about the build and the runtime. Are we able to install the dependency on that specific package, or are we not able to do that? And why we cannot install it? We of course collect all the dependency tree. So when you install something, we want to know that everything direct and transitive are learned by the system. We learn about performances, so we can see if there is an increase, switching different version, if you use one NumPy or the other, and we collect this information. We have ABI compatibilities information, so we want to know that when you install it, it's actually able to run because there are all the ABI available. We have security information, so CVE, and we have security analyzers in order to provide this information. And we have also source code metadata information. So these are important, for example, when you want to work on some projects that are open source, and you want to know basically the status of that project. If the community is reliable, if they are following some CI/CD practices, security practices, they have policies for all the things that are important in terms of code, tests, everything that should be basically taken into account when you want to create a project. In this way, they can decide and say, okay, we'll use that package because I know that is reliable and I can trust it. I can trust the community working on it. Recommendation. Thanks to all this knowledge we collect, basically Thoth is able to give a recommendation based on what you actually need. So I can decide what I want in this case. I will not just say pip install this version. I can say I want this version because it's the most performant. I want this version because it's the most secure, And I want the latest version, maybe because I'm starting to work on a project, I want just to have the latest and greatest. But there are, in this way, the developers, including the data scientists, can choose which kind of software stack they want. And how do we provide this knowledge? We have a recommender system. The recommender system is based on reinforcement learning. This topic will not be addressed, unfortunately, in this topic because we don't have in this talk because we don't have the time. But I will leave you the link to the video in the slides that you will get later, and you will be able to see how the reinforcement learning in Thoth works. And we have several integration. Our API is integrated in a CLI, in a bot. So we have GitHub application and bots that you can install on your project repository, and they will manage the dependencies for you. We have source to image builders if you want to use basically container images and build them and receive recommendation on performances or security. We have optimizing deployment pipelines, so the user will be able to see reports of which kind of model should be used for a certain application. And we have what we will discuss today, which is a Jupyter Lab integration that is made for basically Jupyter notebooks. So how does Thoth help solve the problem? Basically introducing a new Jupyter Lab extension. This new Jupyter Lab extension is called Jupyter Lab Requirements. It's available on PyPI and allows you to manage dependencies and store everything in the Jupyter Notebook metadata. So as we said, we can always provide the notebook with some manifest, but why should we do this job when we can basically merge them and have one standalone experiment that I can provide to the others. And this is what Jupyter Lab extension is trying to do. It wants to help the data scientists provide to obtain the reproducibility and share safely their work. And all the information required from the dependencies, so pip file. Thoth recommender system follows the PyPI recommendation for dependency management files. So use pip file and pip file logs, where you can find all the information related to the package, the version in the direct and transitive one, and also the hashes that are present there and from which indices this package has been installed. Then we also store which type of dependency resolution was used, could be Thoth or pipenv at the moment. And we also store configuration files specific to Thoth because Thoth requires some more information for providing a recommendation, which is basically the runtime environment. As we said, everything can impact your application. So Thoth is able to include this information. Should I run this application on this operating system, on this Python interpreter? Can I use this hardware for the application, or is it not going to work? So all this information can be answered, and Thoth has all the configuration and information that anyone that is working on the project, so the authors need, and the consumer will find once everything is wrapped and ready to be used. How to use this Jupyter Lab requirements? Jupyter Lab requirements provide 3 ways to interact. So there are the famous Jupyter magic commands. You can basically run this command in the notebook cell when you start a notebook. We have a CLI. The CLI is made for automation. Maybe you want to run a test, you want to install the dependencies before doing some other task on the notebook. And this can be used, for example, to extract the content of the notebook related to dependencies and install them. And you can integrate basically in your pipelines. And then we have also a UI for those that want to use the UI, you also have a UI that help you add the dependencies, set everything related to the dependency, and then install and lock everything. And everything will be stored in the notebook metadata. So let's have a quick look of these three cases. The magic commands are are basically initialized called Horus. Horus is the name of the magic commands and also of the CLI. So you can run Horus lock, Horus requirements add, Horus set kernel. So all of these commands are available, and you can just see the help to see what they are. They're also described in the repository, of course. The command line interface, as we said, we can use it for automation, integration in CI/CD pipelines, and it's available also with when you install the extension. And then we have an interactive UI that basically pop up, open a dialog box when you can add a dependency, from which package, which version. We will introduce also from which index in a future feature. And this will help you automate basically all the dependency requirement part. So if you want just to try, you can basically go and install it on your machine and run these commands that are described here. Or we can do another thing, or you can do another thing actually. So you can actually run this a tutorial on the managed dependencies directly on the cloud. How to do that? So the dependency management tutorial that you will find linked at the end on the slides is also available here in the, if you see on the bottom of the slide. The tutorial will cover the dependency management and a little bit what we discussed today. There are also linked video and documentation if you want to know more about the reproducibility problem. And there are 4 cases that you will basically experience. First, if you start a new notebook, what should I do if I have a new notebook and I want to manage dependencies with this extension? 2, if I want to create dependency for an existing notebook. So now I have a notebook, but I want to make it reproducible. So this can help you basically integrate with our extension and allows the other to run your experiments today and also in 1 year. Then we have also convert, let's say, tutorial. If you have pip commands, as we said, they are not going to provide you or allow you to have reproducibility. So what we want to do is to provide an easy way to convert those notebooks. You can just run a simple command and the notebook will be completely converted in the cells that that provide the pip commands. And then you have basically the use of the consumer. So someone already created the notebook and this is reproducible. We can check that also when we start a notebook. There is Horus check command, you will see. And this will give you basically the possibility to just run a command and start working on that environment. Where do you run the tutorial? The tutorial is available on Operate First. So Operate First is another AI COE initiative at Red Hat. And what we want to do is basically open source all operation. We have a community that maintains workloads and interacts with user working there. And what we are trying to do is basically having AWS of Google Cloud, but open. You can learn all about SRE and how to maintain cluster and applications. And in this way, you can have an overview of what is happening when you actually run some specific workloads. On Operate First, there is a new project that was introduced by the ICOECI, which is called Project Meteor. What we want to do basically with this Project Meteor is that you're able to provide a GitHub URL, and that GitHub URL in the service will create 2 products. One is the Jupyter book, where you can have the tutorial explained, and one is a Jupyter Lab environment, where you can actually run the tutorial, which is what you are going to use actually today or when you have time. So this is the interface for the Meteor website. In this way, you can basically just introduce the GitHub URL, and you will basically redirect it to this page, and you will see that for my repository URL have been triggered 2 pipelines. You can have a look at them just basically clicking to show details, and 2 products will be created. One is the Jupyter Lab environment, which is available on Jupyter Hub on Operate First, And the other one is basically the Jupyter book, where you can read and have a look at what are the cases and what we are doing. This is an example of the Jupyter book. Basically, you have all the description, an example of what you will find. This is the Jupyter Lab environment provided through Project Meteor. And basically, you're ready to do the experiment, the tutorial running on this open environment. Let's have a look at the conclusion. So it's the last part of this talk. So thanks to this new extension, we basically don't need to worry about dependencies. What you do is just request packages, and the system will make sure all manifests locked to certain version are present in the document metadata relative to everything that concern the dependencies. So every transitive and direct dependency will be there, and all the hashes, and also the configuration file if you use Thoth resolution engine. If you use pipenv resolution engine, that configuration file won't be there because it's not required. And then once we can say now that this notebook can be shipped standalone, and the Jupyter notebook with embedded information can be used also in containerized process, because finally you can use this in an automated process without worrying the dependencies are missing because they are stored inside the notebook. And you can share safely those notebooks. So the consumer will be just able to run one command that you will learn in the tutorial, and they can just start the experiment. So at this point, we can say that reproducibility can be achieved if we follow some specific good practices. So providing this manifest, having all those information that can be shipped in 2 different files, of course, but if you want, you can also use this Jupyter Lab extension, and you don't have to worry about that anymore. So here you find basically links, more documentation to Project Thoth, and more material about what we do. You can have it on YouTube. There is everything we do every week, and there are more components if you're interested also to contribute and help us on this project. We also have the link to the tutorial, and there you have all the information about Operate First and Project Meteor. And if you want to follow us, you can also go on Twitter. But in general, I hope you enjoyed the talk, and you will enjoy also trying the tutorial. Please provide any feedback. We are always happy to help the community or who wants to join us in our projects, also to improve the extension, or if you want to introduce new features. I want to thank everyone at the Open Data Science Conference team for inviting me, and now I'm open for any question. Thank you very much, everybody.